4/24/23. Okay. We're going to teach you about a box and whisker plot. I got to teach you scale drawings before next week. State testing. All right. Box and whisker plot kind of goes with mean, medium, and mode. It's a way to represent data. Last week, Kevin and you guys created this graph. So this is one way of representing data. I'm going to show you a different way of representing data.
Can we draw
right
this
now.
Again?
Huh?
Can we draw that again?
This I might be dealing with Wednesday or Thursday. So we will be using this information later. All right. So I'm going to give you a list of numbers that you will copy down. All right. 8, 6, 10, 4, 12, 2, 18, 16, 14. So we're going to write those down. We're going to start in our notebook and then we'll head into the packet. But it makes sense right now to do it in your notebook. We will not go in order in the packet. We're going to skip a couple pages and whatnot. All right, so we're going to create a box and whisker plot. Then you'll learn how to read a box and whisker plot. Step number one is put them in order. Okay, so go ahead and put them in order. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18. Wonder if I did that on purpose. Huh. All right. Step number 2. No.
Mode? Range?
No.
Medium?
Find the...
Middle?
No.
Mode? Medium?
Minimum and maximum. Find the minimum and maximum.
Can you just write biggest and smallest?
No, because they use these words. You can write min and max.
Wait, is it range?
No. You would need these minimum and maximum for range, but it's not. What's minimum?
2.
2. What's the max? 18. Good. All right, number 3. Find the median, which is the middle number. So find the middle number. So I'm going to cross the 2, the 18, 4, 16, 6, 14, 8, 12, circle. So the median equals 10. Are we okay so far? Yeah. Do we understand what minimum and maximum is and a median? Okay.
Yeah, it's
Okay,
10.
middle number is 10, median, minimum and max. All right, so this will be new. I mean, minimum should not be new to you. Maximum should not be new to you. Right? Maybe the vocabulary is new, but it makes sense. Maximum number, the biggest number. All right, here's step number 4, which is new to us. We haven't done this. Find lower quartile and upper quartile. Of course you did it on Alex. I love Alex. It introduces it to you. Which reminds me, guess who hasn't logged in the longest time?
Dylan.
No, you.
I knew it.
Yeah, I logged in.
Yeah, some of you logged in, but then don't do any topics. Laugh, but then when I call home, Dylan, March 20th was the last time you logged in.
You always say you do that. You're gonna do them and have it, and you never.
All right.
Yeah, remember?
Lower quartile, upper quartile. All right. So this is new, really weird, but it's super easy to find out. Okay, lower quartile is the median of the first part of the numbers, of the lower part. Okay, upper quartile is the median of the upper half. Now, what does median mean? Middle. So I'm looking for the middle number of the lower part and the middle number of the upper part. How do I divide lower and median? Upper and lower, it's by the median. So you don't include the median. What number is in the middle of the lower numbers?
4 and 6.
4 and 6. So basically 5. So we abbreviated LQ is 5 because that's the median of the lower part, right? Okay, what's the upper quartile?
12, 14, 16, 18.
What is the median number of those numbers?
15.
So here are the upper numbers. What's in the middle? 15. So we abbreviated upper quartile is equal to 15. All right, are we okay with this?
Yeah.
Okay, now we have all this information. Now we get to graph it. Here's how you graph it. You're going to draw a horizontal number line. Can we get the numbers? I guess. Yeah. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. Can you guys fit in 0 to 20? Go into the other page. Okay, so we put a dot for each of the numbers that we found. So you don't put a dot for every number that you got. You don't put a dot on 2, 4, 6, 8, 10, 12, 14, 16, 18. You put a dot on minimum, maximum, medium, lower quartile, upper quartile. So you just need 5 dots. 5 dots.
2, 18, 10, 5, 15.
Yep. So 2 and 18. So you put a dot on the top. It's a floating dot. On the 2, a floating dot on the 18, a floating dot on the 10, 5, and 15. You need 5 dots. On the 2, the 5, the 10, the 15, and the 18. Basically in the numbers that we saw. So on the 2, the 4, the 10, the 15, and the 18. All right? Now, a box and whisker plot. The reason it's called a box and whisker is because when you fill this in, it's going to look like a box and 2 whiskers, like cat whiskers. So the first 2 dots are connected with a line. The last 2 dots are also connected with the line. Then the middle dots are connected with rectangles. Hence, it's called a box and whisker plot. A box and whisker. So you have 2 boxes and 2 whiskers. A box and whisker plot. So this is, you'll see this graph, and then you have to be able to read it. From this graph, you should be able to identify the minimum, the maximum, the median, upper quartile, and the lower quartile.
Oh yeah, here you did this for your TRF.
Who did it?
Ariel or TRF on IU.
Oh, she got it from Alex. All right. This is 25% of your data, 25% of your data, 25% of your data, and 25% of your data.
Oh, I was doing this earlier.
We need to control ourselves. Each section is 25%. Think about it. Your median is the middle number, right? This middle dot is your median. So wouldn't that also represent 50%? Like 50% of the numbers would be here. Because sometimes they'll ask you, you know, is your lower quartile 25, 50%? So each section is 25% of your data. All right. I want you to the best of your ability, trace your left hand. It has to be your left, not your right. It has to be your left. Sorry, lefties. Here's another day where you're just sucks to be you.
I can't even write it. I don't have enough space.
I'm sorry. Can you turn the page?
Oh,
Seriously?
Yep. I thought we had to do it done. That's all.
No, we're gonna do another problem. So here's my left hand. Has to be your left. There's a reason. The math makes sense with the left. The math does not make sense with the right hand. Has to be your left hand.
It's coming out chueco.
It's all right. Don't judge your hand. It's fine.
Yeah.
Okay. We're gonna draw a turkey now. Okay. Which finger has the maximum power?
The thumb, no,
Yeah.
middle.
The thumb. That's why we play thumb wars, right?
Oh yeah, you're right.
So your thumb has maximum power. So this is your max. Maximum. Your thumb has the maximum power. So that means when I'm looking at your box and whisker plot, whichever is on your thumb, the fifth dot, that's your maximum. Which one has the weakest minimum power? Pinky. So we call the pinky the minimum. This is a way to help you remember what each dot means.
Then the ring is the lower quarter.
Yeah, but before we do that, which one's your middle finger?
Median. The median.
So your middle finger is called the median. This is the only time we can talk about your middle finger. Being in the middle also means the middle number. So median, middle finger, there you go. And then this would be your lower quartile, and this is your upper quartile. So if you're trying to remember, gosh, what does this dot mean in my box and whisker plot? I don't remember. Is that my minimum? Is that my maximum? Gosh, I don't remember. Well, you look at your left hand and you go, okay, well, this one's my minimum. This one's my maximum. This one's my medium, my middle finger. Oh, so it's one of these that is my upper. Okay? So it lessens the amount of memorizing you have to do. So your left hand, it doesn't work with your right hand, only works with your left hand.
Because if you wouldn't the right, wouldn't the thumb
It'll
be
be
the
opposite.
lowest?
Yeah.
Wouldn't the thumb be the middle?
Right, and it's like, it makes sense that this would be your maximum power, maximum number. And this is your minimum, your lowest number, no power, minimum. Okay? Any questions so far? All right. Okay, let's start on page 8. Let's start on page 8. We might go back and forth. But let's start on page 8. Page 8, please. Okay, this is a box and whisker plot already drawn for it. So we're reading it. Each dot is a finger. There's 5 dots. 1, 2, 3, 4, 5. There's 5 fingers, okay? So, the incubation time and days of a dove, the different types of birds, are observed and plotted has been drawn. Read the plot and answer the questions below. Okay. Write the first quartile from the given plot. So what would be the first quartile? What dot represents the first quartile, also known as lower quartile?
The second.
11.
Second dot. Very good. So it's the second dot. Lower quartile is your ring finger, your second dot. Now that to me is not 11. So let's figure out what the graph is being divided by and what that dot would be. What I'm going to do is I'm going to draw a line here to help you.
Divided by 10.
Ooh. It's right here.
I thought that was
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, it's in between 1, 2, 3, 4, 5.
60.
Oh.
So 50.5.
Yeah. Great. Not the easiest answer.
I think all of them are like that.
All right, what's the maximum? What dot is that?
Your thumb.
Your thumb, which is the last one. Let me draw it. Oh no, this one's okay.
Oh, that was 35.
That one's 35.
35, yeah, definitely beat the 15. I said 15.
Median. What dot is your median?
Middle 20.
25.
Point 20 up, 20.5.
6.
I mean, it's in the middle. It's fine. It's not a big deal. All right. Okay, distributions, brand models, this is the data of the smartphones. Okay, so here is the data for the number of smartphones distributed in 9 months is collected. So we're trying to figure out, okay, so how many phones were collected between the months of January and September? Right, the median. So median is what number, dot?
40.
Third dot, so that would be 40. What is the least number of smartphones? Least would be minimum.
34.
But sometimes what kids do, they'll make this mistake. They'll look at this and be like, oh, it's 20. And I'm like, why is it 20? Well, because my number line starts at 20. I'm like, well, that doesn't matter. It's where this dot is, not where this is. All right, so what is it? 34. And the third quartile, does anybody know a different word for third quartile? Upper quartile.
28.5.
Upper quartile is
48.
this one, 48.5.
Yeah, and then he said, how's it 48?
Yeah, 48.5.
Okay.
Okay. Let's go back to page 6. Page 6. Huh? Page 6. Okay. What's the first thing we need to do? Put them in order. So go ahead and put them in order. Go ahead and not talk and put them in order.
We do number 1, right?
Yeah, number 1 on page 6, put them in order. You can put them in order down here. You can put them in order over here. I like to cross them out as I go so I don't repeat it. There is a number that repeats. There is a number that repeats. So you repeat it. It repeats, you repeat. Alright, did we all put them in order?
Yeah.
Okay. So, 1, 2, 3, 4, 5. Minimum. What is the minimum number?
8.
Second time you mess up on minimum.
39.
Maximum.
39.
Okay. So, what is Q2? Q2 is median. Okay. That's the first one you find. But Miss O'Malley, they're asking me for lower quartile first. Cool. You can't find lower quartile until you find median. Median is the one you have to find next. Cross them out. Literally cross them out. And this is how you double check your work is. Yeah. Count how many marks, dashes did you do over here? 1, 2, 3, 4, 5. Over here, 1, 2, 3, 4, 5. Okay, so you know you have 5 on this side, 5 on this side. You found the median, which is 23.
And the lower is 11.
Lower, you like over here. So then I make an X. And I circle it, and 11. Okay? On the SBAC, if you get this question, don't try to do this in your head. There's too many stuff to it's not, the math is not hard. It's just so many things to make sure they're all in the right order that you don't want to get it wrong because you try to do this in your head. And what's the upper quartile?
32.
Okay, 32. Now we have to create it. Do I put all the dots? No, I'm going to graph 1, 2, 3, 4, 5. 5 dots. So graph it. 8, 39, 11, 23, 32. 5 dots. 5 dots. 1 for each of these numbers. The first 2 are connected. The last 2 are connected. Those are your whiskers. Then we connect this with the box and connect this with the box. And that's it.
It's kind of easy, just a lot of numbers.
Yeah, the first part's like, it's just tedious. It shouldn't be difficult. Shouldn't be difficult. All right, can you guys start number 2 with putting them in order? Putting them in order. All right, so like I said, we'll do box and whisker plots more tomorrow. Today, I'm going to show you what I showed my other kids on Friday. Scale drawings. Scale drawings. It's pretty fast, pretty easy. All right. And I actually use you guys as an example, second period. Okay. So here I have my triangle. Let's say this is 6 centimeters, 5 centimeters, and another 6 centimeters. Okay. And I'm like, oh, I'm going to print out this triangle that measures this exact measurement. And I'm going to post it in my classroom. Now think about it. 5 centimeters is this big. 5 centimeters. 6 centimeters is that big. If I were to print out a poster that's 6, 6, and 5, is it going to be easy for my students to see? No. That's pretty small, right?
Not really, no.
So I decided to call upon the Spider Lab kids and be like, can you make this triangle 10 times bigger?
Oh, yeah.
All right, so I can post it and the kids can see it.
60, 60, 50.
Right. So we call that a scale drawing. So it's like a scale. The scale factor is 1
Wasn't this
to
on homework?
10. Yes.
1,000%.
Yeah, that's, wasn't it 3?
Yes, it was 3.
Oh, okay. No, when I do it on Alex, it always says it's wrong.
Well, those are the easy ones.
Huh?
The hard ones is when like they're a decimal. I'll show you today, hopefully. Okay. So I want a scale factor of 1 to 10. So I'm going to blow this up 10 times. So I'm going to call this X, Y, Z. So can you tell me what would be the new measurement of X, Y, Z?
A, B, C.
If the scale factor is 1 to 10, what would the new measurement of X, Y, and Z be? So this is the original one. I'm going to have a scale factor of 1 to 10, which means 10 times bigger.
X is
60,
60.
60, 50.
Y is
So X would be what?
60.
60. What is Y? 50. And Z? 60 centimeters. So it's a scale factor. Have you guys ever been to Las Vegas?
Yeah.
So if you've ever been to Las Vegas or seen pictures of Las Vegas, one of the first things you see when you drive up is a pyramid, right? So is that pyramid the same size as the pyramid in Egypt?
I forgot.
No, it is smaller in Vegas. And you keep driving, and then you see the Eiffel Tower. Now, is it bigger or smaller? Smaller. But it's a scale of it, meaning it's proportional to the real one. So they did this. They took something bigger and made it smaller to fit the Vegas Strip.
So wouldn't that just be division?
Yes. So if you're going big to small, you divide. If you're going small to big, you multiply. If you ever played with a Hot Wheel, if you flip it over, it will have the scale on the bottom of a Hot Wheel. So if you have a toy Mustang of a Hot Wheel, you flip it over, it has a scale at the bottom, so it's proportional to the real Mustang. All right. So let's. Okay. Okay. Draw me a 3D rectangle. Small. So here's how you do a 3D rectangle, not on our phones. Well, I don't understand why we would be on our phones unless we're being distracted by something, which would be terrible. Okay, this corner right here. This corner, we're going to go 2 over and 2 up. So 2 over, 2 up. From this corner, 2 over, 2 up. Then, so we stop there to make sure you're all caught up. So I went 2 boxes over and 2 boxes up. 2 boxes over and 2 boxes up. Of course, if you have graph paper, this is so much easier. And then you're going to connect these 2 dots on the top. And then we connect these 2 on a diagonal. And these 2 on a diagonal. And then from this top dot, I'm going to go down 2 and put a dot. From this dot straight down 2. And we're going to connect. And then this corner to this corner. And we have a 3D shape.
It looks like a square that would like just smush.
Now I'm going to make a bigger one.
Whoa.
A bigger rectangular prism.
Yeah, I like it.
Bigger one.
Trippy red.
Down, over 2, up 2. Over 2, up 2. Just like so. Then I'm going to connect the top. Ladies, here, go down 2. Here and there. So did we make this shape bigger or smaller? Bigger. Okay. The scale factor is 1, 2, 3. 1 to 3. So I'm going to say this is 1, 3, and 7. So what is it, Ariel?
300 times bigger?
Not 300.
Well, like 300%, sorry.
Yeah. So, what is X, Y, Z? Measure. X, Y, Z. So, what is the value of X, Y, and Z?
21, 9, 3.
Yep. Okay. So what is X?
21.
21. Y is
9.
9. And Z is 3.
They're basically multiplied.
If you are going small to big, how do I make a number bigger? Times. How do I make a number smaller? Divide. So if you're going from a small shape, so if I'm going from big to small, what math am I going to use? Divide. If I'm going from small to big, what math am I going to use? Makes sense, right? All right. So let's look at this worksheet. Okay. Scale factor of A to B is 1:2, which just means 2, 1 to 2.
Also 6.
Now they go back and forth. I need X and Y. One's on the big shape, one's on the small, one's on the big, and one's on the small. What are your answers for X and Y?
10 and 6.
Well, he needs to get on the right side of the worksheet first.
3, 6, and then we got 12. 10.
6 and 10, like that?
No, other way. Oh, 10 and 6. Oh, 10 and 6.
So X is down here, which is from the big one. So that would be 10, because it's twice. And then half is 6. So you're going to go back and forth. You're going to multiply and divide. Multiply and divide. Okay, let's do number 2. Now my scale factor is 1, 2, 3.
Number 3 is tricky.
1 to 3. So we're looking for X, which is on the big shape, so it should be a big number. Y is on the small shape, so it should be a small number. Our scale factor is 1 to 3. So you're either going to multiply by 3 or you're going to divide by 3, depending on what direction you have to go.
What about 3?
Give me a decimal. Okay, what is X equal to? On number 2.
12.
You either have to multiply by 3 or divide by 3. Neither of those numbers will give me 7. Y. What is Y?
3.
3. So you're either going to multiply or divide by 3. Whatever this number is, you're going to multiply or divide by it. All right, number 3. X is the easiest one.
Forward.
X and Y is a decimal. It's not a very hard decimal, but it's a decimal.
4.
So what is X?
4.
No.
It's 5.
5.
Yeah, 5.
And Y?
2.5.
Yep.
0.6.
What is 20 divided by 4?
1.
No, wait, 5. I was looking at number 4.
You say 12 or 20?
20, because this number is 20.
5, yeah.
That's how we got that number. We're literally dividing by 4.
Yeah.
All right, number 4. What's our magical number?
7.
7. How do I know it's 7? It's in the directions. So here, if you're going from big to small, you're going to divide by 7. If you're going small to big, you're going to multiply by 7. Draw arrows if that makes it easier. How do I go from here to here? Small to big. Small to big is multiplication. What am I going to multiply by? 7. So what is Y?
14.
That's how easy this is.
And then X is 1.
Then I'm going to take this number and go this way. Hey, I'm going from big to small, so I'm going to divide. What number do I divide by? 7. So 14 divided by 7?
1. Kind of makes more sense.
What about X and number 5?
Will be a decimal.
A huge decimal.
5.
No.
No, it's only 0.6.
Yeah.
Dude.
Thank you.
Wait, then what's Y? Wait, what's Y for
35 divided by 5.
7?
And then 3 divided by 5. So 3 goes inside and 5 goes outside. not the other way around.
I did 3 divided by 7. That's X.
Totally.
So I got blah 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 blah.
0.67.
0.6.
And then number 6.
Respectfully.
Number 6, what do we get for X? Y? We're good? Alright, to the back. Stop. It's kind of weird that you would want to do that to him. But that's fine. Here, I'm not here to judge. Okay. Number 2. We're going to start with number 2. We're going to start with number 2. This is also scale drawings. But the trick about this, it's not 1, 2, 5. It's not 1, 2, 3. There's no 1, so it makes it harder, but not really. Okay. John, an architect, used a scale factor of 1 to 20. Okay, I lied. It does have a 1. The actual car park has been designed to be 18 feet long. Determine the length of the car park depicted in the blueprint. All right. So there's no drawing. Boo-hoo, boo-hoo. What you're going to do is you're going to set up a proportion. A lot of problems on your state test can be solved for proportions. So if you read something on the state test and you get stuck, try a proportion. There's a lot of math problems that can be solved with a proportion. Okay, read the first sentence and write your first fraction with units. First fraction, first sentence. First sentence, first fraction, write it down.
120.
Okay, write the units. What does the 1 indicate?
Inches and then feet.
20 feet. It's important that you write the units, so the next number, you plug it in the right spot. What's the next number?
18.
18 what?
Feet.
18
feet. So where does that go?
Bottom.
Bottom. How do I solve a proportion?
Divide.
No,
Oh.
before.
You multiply.
Butterfly method.
Yeah, the butterfly method.
Butterfly method. Butterfly method.
0.9. I got 0.9. 0.9.
Butterfly method. Number 2. We're on number 2. Yay, us.
Good job.
Because some of you are on number 1. I mean, that's good. The reason I went this one because there's no decimals in your problem, so it's less scary to start with. So it'll be 1 times 18, which is 18, equals 20 times x, which is 20x. What do I divide by? 20, because 20 is on the x. This is why we show work and we go slow. Which number do I plug into the calculator first?
18.
The 18. Top number goes in first. The second number goes in the bottom number goes in second to your calculator. What is 18 divided by 20? 0.9. So what are our units with 0.9? Inches, because that's where the x is, on inches. All right. Can you please write down the proportion for number 3? Please write down the proportion for number 3. All right, what is our proportion for number 3?
1 over 1.6.
Feet. Okay, 17.4 inches. Where does that go? Top, because it's inches. This is why it's super important that you write down the units. Not because it makes your math easier. Well, actually, it does make your math easier because you plug them in the right spot. Some kids always think that the x goes on top. Not always. So you do the butterfly method. 1 times x.
Equals
1x, or just x. And then 1.6 times 17.4. You can go ahead and type that into a calculator.
27.84.
27 point what?
84.
84. Divide by 1, divide by 1. Hey, you get the same answer. So it's 27.84 what? Feet. This is why we write our units. So hopefully you realize, like, hey, the x is in the feet, so my answer should be in feet.